All right, in this video, we're going to solve for the starting value. In these particular questions, what we're going to be asked is what value would you have to start with in order to end with a particular value? Okay, so look at this example. It says how much should be deposited? Okay, how much is deposited? That's what's happening at the beginning. Is we're depositing some money, and it's saying how much should be deposited into an account that gives an annual interest rate of 6.17% compounded daily. Okay, so this is another one of those situations where it's an annual interest rate, but it's compounded daily, so we're going to have to divide by 365 so that the money will become $5,000 in 700 days. Okay. All right, so we need our rate, 6.17%, that's the percentage, but the rate is going to be the decimal. So we need to take our 6.17, divide by 100, and we get 0.0617, okay? So our money of t over time is going to be equal to some amount of money invested, which we don't know, so that's going to be money at time 0, okay? So that's the thing. So the starting value is time 0. It's the function value at time 0. So it's going to be money at time 0 times 1 plus, because it's a growth, and we have to take our rate, 0.0617, divide it by 365. Why are we dividing by 365? Because our interest rate is yearly, it's annual, but we're being asked about days, and it's compounded daily, okay? So we have to divide by 365, and then we have to do to the power of t, and t is in days, okay? And so now we know what m of t is. After 700 days, so that's m of 700, m of 700 is 5,000. We're told it's going to become 5,000. So 5,000 is the ending value. And so we're going to set this up as an algebraic equation. We're going to put 5,000 in for m of t. So we're going to have 5,000 is equal to m of 0, that's the starting value, times 1 plus 0.0617 divided by 365 to the power of 700, because time is 700, okay? And this is m of 700 that we're plugging in here, so we have to put 700 here. So now to solve for m sub 0, all we have to do is divide by this. So we divide by 1 plus 0.0617 divided by 365, whoops, I did it backwards, 65, to the power of 700, okay? And so over here, that's going to cross out and leave us with just m sub 0. So that means over here, we have to do the exact same thing. We have to divide by 1 plus 0.0617 divided by 365 to the power of 700. Okay, and so when this crosses out, okay, all we're going to have left is m sub 0. So m sub 0 is equal to this. So this is our answer. Okay, so let's go ahead and calculate that in a calculator. We'll do m sub 0 is equal to, and we'll key this in to the calculator. Okay. All right, let's look at that again. It's 5,000 divided by, so 5,000 divided by, let's see what we have. Parenthesis 1 plus. Okay, so parenthesis 1 plus, and then it's 0.0617 divided by 365. Then we're going to close the parenthesis, and we're going to raise it to the 700th power. Now you could do these things in pieces if you want to, but this is what you have to calculate. And when we press enter, we wind up with $444, or sorry, I did 500. That was an accident. I messed that up. All right, so let's go up and we're going to grab this and I'm going to edit it. I meant to make this, that was an accident. This is supposed to be 5,000. Whoops. Okay, now execute. So $4,442.06 is how much we need to deposit. 4,000, so our answer is 4,400, and we put a dollar sign here, $442.06. Now, if you're told to round to the nearest whole number, then you will you'll leave this off, and it'll just be $4,442. Okay. All right, let's try another one. All right, so this one is saying how much should be invested in an account that returns 8.5% per year compounded continuously so that you will have 12,000 after 48 months. Okay, so we're going to leave this in years, but I want you to notice this says 48 months. So we need, this time, instead of converting the rate into months, we're actually going to convert the months into years. We know that 48 months, okay, is equal to 4 years, okay? And so our time, instead of 48 months, we're going to say 4 years, okay? And so time is going to be 4. All right, and so our M of t, well, we need to get our rate. Our rate is going to be, we got to do 8.5 divided by 100, and that's equal to 0.085. And so M of t, our ending value, is going to be equal to our starting value, which is M0, times E, because it's continuously, e to the power of 0.085 t, okay? Now, we want to know when t is 4 years. So this is going to be m of 4, okay? So we're going to have m of 4 is equal to m of 0 e to the power of 0.085 times 4. Now notice this 4 is still in the exponent. You could put parentheses around the whole exponent if you want to, okay? Now to solve for m0, we're going to do the same thing we did in the last one. We're going to divide. We're going to cancel this e. So we're going to divide by e to the power of 0.085 times 4. And we're going to do the same thing on this side. We're going to divide by e to the power of 0.085 times 4. Okay? And on this side, it's going to cancel out. Okay? And so m sub 0, or m of 0 is going to be equal to m of 4. And what is m of 4? We got to replace m of 4. M of 4 is 12,000. We want the n to be 12,000. So it's going to be 12,000 divided by e to the power of 0.085 times 4. So let's switch over to the calculator. And we'll do 12,000 divided by e to the power of, I'm going to do that parenthesis, 0.085 times 4, close parenthesis, enter, and we get $8,541.24. So 8541.24. So 8541, is that right? Yep. 0.24. And so the answer is we have to invest $8,541 into an account that returns 8.5% compounded continuously in order to get $12,000 after 4 years or 48 months, okay? All right, so basically all you do to solve for P is you just divide the exponential part of the expression, you divide the ending value by the exponential part of the expression, and it gives you the beginning value.